Hi everybody, we continue the lecture of integral and today we start the integral by substitution and we start how we can do integral by substitution because some of the integrals we cannot solve in the same simple methods and we have to use special methods like integral by substitution. Okay, as you see here, in the substitution, for example, in the first example, integral of e power minus 3x plus 2. First, I choose minus 3x plus 2 as a u. Then I make a derivative, okay, and find the dx from here. Now I put instead of minus 3x plus 2, u in this situation will be e power u du d. And instead of the dx, I put du per minus 3. And now we have this one. And we know the number no effect in the integral, and the result will be minus e power u per 3 plus c. And we can put instead of u minus 3x plus 2, and it will be the first result. In the second example, it's almost the same method. 2x plus minus 1 is the u. The derivative of from the here, then du, derivative u equal to dx. And we can find the dx equal du per 2. Now I put these and this in the formula. Instead of dx, I put du per 2. And instead of the 2x minus 1, I put u. And it will be like this. And the derivative of the minus e power u per 2 du will be minus e power u per 2 plus c, and we can put instead of the u 2x minus 1. Or if we for this type of the question 1 per 9 minus 2x, 9 minus 2x I can put instead of this I put u, derivative of this equal minus 2 dx because of this, and I put instead of the 9 minus 2x u, and instead of dx I put du per minus 2 because as you see here I can find dx equal du per minus 2, and I know the integral of the 1 over u is ln u, and this is the number, it's outside. Then I put instead of u 9 minus 2x, and the result will be minus half ln 9 minus 2x plus 3. Or in the cosinus integral cosinus 3x minus 1, I can put 3x minus 1 instead of u. I found the derivative of this, du equal 3 dx. I can find dx, it is a du per 3. Now I can put instead of dx du per 3 and the cosinus u, and because it's a number go out, and the cosinus integral is the sinus u plus c. And I put again instead of u 3x minus 1, and the result would be the final result. Over here, okay, under the radical I can put 1 minus 6 equal u, derivative will be du equal minus dx, and instead of dx we can put minus du. Again, instead of 1 minus 6 I put u, integral of the radical u, and I convert the radical to the power. It will be minus u power half du, and for the integral it is plus 1, it will be 3 over 3 per 2, and divide per 3 per 2, and the result, final result will be this. Then we put again instead of u 1 minus 6. The other situation, if we put here u again, and the derivative of this will be 3x plus 2. As you see here, I see 3x plus 2 here, then I can write derivative u prime is derivative of du, and the multiply e power u will be du, because I know the derivative of this is this one. Then it will be derivative here, e power u du. And we know that from the formula, eu is the result of this equation. Integral of this formula will be e power u plus c. And we can put instead of u, x power 3 plus 2x, and it will be the final result. And now we understand if we have a derivative of u in the formula, we can easily also solve the equation like this method. For example, here you see cosinus x is u. Okay, derivative of the this formula will be minus sinus. Then we can see in the here we have a derivative of u prime with the minus sign, and we have a u instead of cosinus x is u. Now it's very easy because the integral of this will be ln u minus l, because the negative sign is here. It's very easy, okay? Because if you inverse the equation and we use this equation, we can find this opposite in derivative. Or, for example, x multiplies sinus x power 2 dx. I put instead of the x2 is the u, derivative will be 2x. I see here is the u prime per 2 because it is the derivative per 2. And this half no effect, but the u prime sinus u integral is the minus cosinus, and half come here. And instead of the x2, I put in the formula u, instead of u, I put x2 in the formula, and the result will be minus cosinus x2 per 2 plus 3. Or here you can see, I can put instead of minus x power 3 u, and I can find the u is minus 3x2, x power 2. And now I know x here is the u prime per minus 3, because the relation is this 2 is the u prime per minus 3. And instead of the minus x3, I put u, and it's very easy. This number go out, and the integral of this system will be e power u per minus 3 plus 3. And I put instead of u minus x power 3, and the result will be this equation. Okay, as you see here again, first I put 1 minus x2 as the u, derivative will be du equal minus 2x. Okay, but here I have a minus 2x, here is the x derivative. Then I can put, instead of x, I can put u prime per 2, you see, and I converted the derivative radical for the power, it will be minus 1 per 3. And now I can make an integral from this, plus 1 will be 2 per 3, and divide by 2 per 3, and also I have a 2 here, and the result will be minus 3 per 4, u power 4, okay, 2 per 3, plus 3, and instead of u, now I can put again 1 minus x power 2, and it is very easily. Then most important things, we have to find in this type of equation relation between the u and the derivative of u, as is the u prime. Because in this situation we can really easily find the integral result. Also you can see here, instead of x power 2 minus 4, I put u, find the derivative, 2x derivative. Now I know it's the 2x, x, I know it's the x is the derivative per 2. Then I can put derivative per 2, u prime per 2. And I know I have a 1 per u here, then it is a u prime here and u here. And because of the relation between 2 and 1 is 2, it comes here. And the integral of this formula is the half ln u plus 3, and I put instead of u x power 2 minus 4, and we can find the result is the half ln x power 2 minus 4 plus 3. Okay. You can see here again the same situation. Integral of e power x multiplied sinus e power x. Again, e power x is the u, and the derivative of this will be e power x again. Then I can say it is a u prime, and it is sinus u. And the integral of this formula is minus cosinus u plus 3. And now I put instead of u e power x, and the result will be final. Integral of ln x per x. Okay, I put ln x as a u. Then an integral of the u, and I make a derivative from the ln x will be du equal 1 per x. Then I can say 1 per x is the u prime. Okay, and the ln x is the u. And the integral of this u prime u du is equal u power 2. And then I can write u is ln x, and we have to put power 2. That's it, plus 3. 1 per x ln x. Okay, ln x is the u, then du is 1 per x. Okay, then I can say this is the u prime, and 1 per ln x is the u, then will be u prime per u, and the integral of the u prime per u du will be ln u plus 3. And then we put, instead of u ln, then will be ln x plus 3. It's very easy, because we have to show relation here. You see, it is the ln x is the u. Derivative, it is of this will be 1 per x, and it is the 1 per x. You see, because it is a u prime, and it will be here u prime. Here is the u prime, and here will be u. And the result of the integral of the u prime per u is as a normal equation, is ln u plus 3. And now we put u instead of the, we put ln x instead of u, will be ln x. Okay. Or you can see the next one. Okay, integral of sinus ln x per x. I put ln x as a u. Derivative, then will be, derivative will be 1 per x. Now I can say 1 per x is derivative. Then it is a derivative, u prime. Okay, it will be u prime. And instead sinus ln x, because it is a u, I put sinus u here. Now, from here we can find the integral is minus cosinus u plus 3. And now is the result. We put instead of u, ln x, and result with minus cosinus ln x plus 3. Or here you can see the other example. For example, cosinus x sinus 2 power 2x. I put, instead of sinus x is the u, derivative will be cosinus x. Okay, then cosinus x here, it will be u prime. And the sinus power 2x, it is a u, and I bring up, it will be u power minus 2. And this is a normal integral, plus 1. Okay, divide 1 will be minus u minus 1 plus c, and will be, instead of u I put sinus, will be minus per sinus x plus 1. And the integral of the x multiply radical x plus 1, x power 2 plus 1. And again, I put, instead of the under the radical is u, derivative will be 2x, and here I can find relation between these two. It is a derivative per 2. I put here derivative per 2, u prime per 2, multiply radical u, and radical u is u power half. And now I add a plus 1, divide, it will be 3. per 2, and I can put 3 per 2 here, and in this situation will be this cancel each other. It will be u power 3 per 2 divides 3 and plus 3. Now I can put, instead of the u, x power 2 plus 1, and we can find the result is here. The last two examples, again, the same. Under the radical, I put u, 1 minus x power 2 is u, derivative will be minus 2x. I can find the relation between these two is the u prime per minus 2, and I convert this radical to the power plus half, plus 1 per 3, and transfer to the up minus 1 per 3, and integral of this, it can be plus 1, divide, it will be 2 per 3, and divide 2 per 3, and the result will be minus 3 per 4, u power 2 per 3 plus c. And now we can put, instead of u, this number, this minus 1 minus x power 2, and the result, final result will be this. And the last step, instead of x power 2 minus 4, I put u, and derivative will be 2x. It is relation between these two. It is u prime per 2, I put here. And because it is here, I can put u prime per 2u. And the integral result will be half ln u plus 3. And now I put, instead of u, this, and will be half ln x power 2 minus 4 plus c. I hope it will be good, and we will continue next method in the next lecture. Thank you, and have a good time.